Here we're asked to find the rational zeros of the polynomial, then write it in factored form. So first thing I'm going to do is find all of the possible rational roots by looking at the factors of the constant and the factors of the leading coefficient. Factors of the constant are positive or negative 1, 2, and 4. My leading coefficient is just 1, so really these are all of my possible rational roots here. So basically what I'm going to do is I'm going to use these and synthetic substitution to plug that into here, into this entire long string of numbers here, to figure out which ones gives me zeros and go from there. So to start us off, I'm going to go ahead and try positive 1 into here. So this is 1, negative 2, negative 3, 4, and 4. Bring down the 1. 1 times 1 is 1. Add these together to get negative 1. Multiply 1 times negative 1. Add these together to get negative 4. Multiply to get negative 4. Add to get 0. And I do not get 0, so positive 1 is not a root for this equation. Let's try negative 1 now. So same, negative 2, negative 3, 4, and 4. Negative 1 times 1 is negative 1. Add these together to get negative 3. And I get, negative 3. Oh, sorry, this is positive 3. Add these together to get 0. Sorry about that. Negative 1 times negative 3 is 3. Negative 3 plus 3 is 0. Negative 1 times 0 is 0. Add them together. Negative 1 times 4 is negative 4. And here I get a 0. So what that means is that because I have negative 1 as a 0, that means I can factor out x plus 1 from this equation here. And what I'm left with is what's remaining from my synthetic substitution. So that means I have x to the power of 3 minus 3x squared plus 0x, because this is 0 right here. So I could really just get rid of that, plus 4. Now, when I continue going through my possible rational roots, I'm going to start with positive 2, but I'm actually going to use the remaining string of numbers here. So what that means is that my synthetic substitution is 1, negative 3, 0, and 4 instead of the longer string that I started with, because I factored out x plus 1. So now I bring down 1, multiply, add, multiply, add, multiply, and hey, there we go. We got another 0 here. So what that means is I can factor it out. So I get x plus 1, x minus 2, and then whatever is left here, my string of numbers, which gives me x squared minus x minus 2. Now I could continue going here, but let's just look at this quadratic here and think about how we could factor it without plugging in numbers into synthetic substitution. I know that I'm looking for a number that multiplies to negative 2, two numbers that add to negative 1, which would be negative 2 and 1. So what that means is that I can factor it even more without using synthetic substitution. It tells me it's going to be another x minus 2, another x plus 1. So my zeros here, my only zeros are going to be negative 1 and positive 2. And my factored form is going to be f of x equals x plus 1 squared, because there's 2 of them here, times x minus 2 squared. And that is my final answer.